Hiya. The purpose of this video is to explain about vaccination and the advantages and disadvantages of vaccination and the ease and difficulty of vaccination in certain circumstances. Starting point for this video is a picture of a virus with various surface antigens. Any of the surface antigens shown could theoretically be used in a vaccination. Purify the surface antigens and inject those into somebody, and somebody would produce antibodies to the surface proteins and would identify therefore the virus when it infected them. If you were asked to state how a vaccine works, you would say that a vaccine is a weakened or dead virus, or is made up of antigens from a pathogen. These are injected into the body. The antigens would induce an immune response, so antibodies would be made and memory cells would be produced. The antibodies would bind to the antigens, but that doesn't solve anything because the antigens themselves were never actually going to cause the disease. They're only present to represent the disease pathogen. But the memory cells that are produced would then remain in the body, and if the actual pathogen did infect the body at a later date, these memory cells would be activated and antibodies would be released again, and they would compromise the pathogen or nullify the pathogen. So let's look at an ideal situation for a vaccine. So we have a pathogen that has an obvious surface antigen that we can use that is very easily manufactured or bioengineered, and the process is quick, it's very efficient, we get lots of vaccine, and it hasn't taken the company very long to produce, therefore the vaccine can be given cheaply. We would try to get herd immunity. What that means is we try and vaccinate everybody in the country, and the pathogen would have nowhere to go. It would have nobody to infect, and you may be able to eradicate the pathogen from the society or from the country or even from the whole planet. And again, in the ideal situation, the vaccine would have no side effects. Another question could be to do with problems of vaccination. One example would be with cholera. There are three specific difficulties with producing a vaccine for cholera. The first one is antigenic variability. That means the surface antigens on the cholera bacteria change over time through mutation, and that means that a vaccine directed towards a particular antigen could eventually be ineffective. The second thing is that the bacteria are multiplying rapidly in the gut and then infecting the tissues from there. The gut is generally out of reach of the immune system, so even if you're immune to a bacteria, you're not going to clear it completely from the gut. In addition, because of the condition that cholera is, the gut is being washed through on a regular basis, so any additional treatments that you have that are ingested are not going to stay in the intestine for long, because they'll get flushed out with the diarrhea. So that becomes an ineffective route of administering treatment. The third thing is common to many diseases. We have such a mobile population now, with people moving in and out of countries on a regular basis, that cholera can be carried from one place to another. It can be carried into areas where it's not commonly found and people haven't been vaccinated, or it can be carried from areas where people haven't got cholera and they move and visit a place where they have and haven't been vaccinated for it so they can catch it. So mobile populations is another comment that you could make in an answer to this point. If we consider the same question but for tuberculosis, TB, then we've got mobile populations again as a factor, but there are three others. Firstly, there's a significant overlap of HIV infection in areas that are affected by TB, and HIV causes the immune system to be depleted, and therefore tuberculosis becomes more common because of that. We've also got the aging effect. Most or the majority of people that get TB are elderly, and as you get older, your immune system gets weaker. So there's a link there. And then, thirdly, of the three additional factors, there are socio-economic factors. There are often conflicts and severe poverty in areas where TB are rife. So those factors make organisation and distribution of a vaccine a very secondary issue. The first issue is having enough food to eat and not being bombed or shot. So there are those four factors there for problems with TB. Finally, I just need to mention MMR. So that's the measles, mumps, and rubella vaccine that in the 90s had a very low take-up suddenly because there was a piece of research published that said there might be a link with autism, and that got significant press coverage, particularly I think it was by the Daily Mail, who thought that the government were trying to hide facts, and big scare story came out, and MMR vaccination rates went very low. The consequence of that now is that increased levels of mumps, measles, and rubella, all of which have significant issues with side effects and death of the condition. It is generally accepted that there is no link between the MMR vaccine and cases of autism. It's just that the symptoms of autism tend to show at around about the time at which the vaccine is usually given. So there is a link in people's minds, but not necessarily a causal relationship. Having said that, there is recent data that autism may be linked to a mercury-containing compound that is in many vaccines, not specifically the MMR or any other, but lots of vaccines use this mercury-based compound. And there may be a link there. That's the latest story. That's something you might want to read up about. But if you were talking about the MMR vaccine, then you would say that there was an autism link. People are worried about side effects and the risks of vaccines, and it's personal choice about whether you should take it or not. The flip side of that is maybe the government to say that everybody does take it, because if a lot of people don't, then the benefits to the people that do are reduced. You tend to need to have high take-up of a vaccine for it to have been cost effective, and of course on an individual level, the risk to an individual, or the cost to an individual, may be high in terms of side effects or a bad reaction or something else, but overall the risks to the society of everybody taking the vaccine are lower, because the damage caused by the disease is worse than the damage caused by side effects to the vaccine. So there's a risk balance where it could be unfair on a particular individual, but overall on society it's a better state of affairs for everybody to have the vaccine, and that makes it a very difficult ethical argument as to whether you should take the vaccine or be forced to take the vaccine or not. Lots to get your teeth into there. You'll need to think about it, play this back a couple of times, and it's a thinky one rather than a doing one or a memorizing one. Try and just think about the topics that I've mentioned.